In this video, we'll be working through the question you see on the screen from the 2023 Ordinary Level Maths Leaving Cert. I recommend you try the question before watching, and if you get stuck anywhere, feel free to ask for help in the comments. I will do my best to get back to you. Check out my channel for a playlist with all the other questions. This is question 10 from paper 2. In this question, we got a bit of geometry followed by a bit of probability. Now to start off, they give us this shape here. They tell us it's a regular pentagon. They tell us all sides are equal, but they don't have to. A regular, that's what regular means. Regular pentagon means all sides are equal. For example, a pentagon has 5 sides. So 1, 2, 3, 4, 5. That's not regular. That's an irregular pentagon. So that's what we're dealing with here. We have an angle inside here of 72 degrees and the length, all of these lengths here are 6. So yeah, I'll put in all of them. They just tell us 1, but that means all of them are. They just tell us this is 72, but all of them are because it's a regular pentagon. Everything's equal in this pentagon. Now they do ask us a specific question, but before I even answer A here, what I like to do with a question like this is I like to fill in everything I don't know. For example, I've already started there. They told me 72. Well, I'm filling in all the other 72s. They told me 6. Well, I'm filling in all the lengths are 6. And I'm finding everything I can. The next thing that would stand out to me is this angle in here. So I would try and fill that out. They tell me this is an isosceles triangle. I believe they told me that, don't they? Well, it is anyway, because we have 6 and 6 both sides. I think they, well, okay, maybe they don't, but no, they do. Isosceles triangle. So we have 6 on either side. This is 72 up here. Doesn't actually look like that. That's way too small for 72. But still, that's what they've told us. We can go ahead and find these angles. That should be quite easy to find. They're the same, x and x. What is x? They all add up to 180. A lot of you are really good doing that in your head. I don't mind doing it slowly. X plus 72 equals 180. Again, just do it nice and slowly. 2x plus 72 equals 180. Take 72 from both sides. 180 minus 72. 2x is equal 108. That x, divide both sides by 2. X is equal to 54. So instead of x, we have 54. 54. So all of these sides here are 54, 54, and so on, all the way around. That's what I like to do before I start a question that has a shape like this. Next thing, I'd maybe think, oh, what's the length on this outside? What's the length out here? And honestly, that looks a little too hard. That's a bit of trigonometry. I could do it. We could find it, but it's a little too difficult. This was so easy. I might as well do it quickly before looking at what the question is. And it's convenient because the question, I had to do that anyway. And I don't think for this whole question we need the length outside, so that's good. And so part A, they ask us, what is the angle CBA? So first of all, some students have trouble finding what angle they're asking about. CBA. Just draw it again basically. Go CBA. There's only one angle they could be talking about. So the angle CBA must be this angle in here. Must be this angle in here. So what is that angle? Well, that's 72 and, 54. My bad. 54 and 54. So the answer is 54 plus 54 equals 108. That's the answer to part A. Now for part B, they ask us to work out the area of the triangle AOB, this triangle up here, but really they're all identical. So I might as well use this drawing here. Actually, well, I guess I'll draw it again. You know what, I'll draw the one they want. This triangle up here, we know that's 72, we know it's 54, we know 54, we know 6, and we know 6. They would like us to work out the area of this triangle, and then they say hence the area of the whole thing. That just means do this first, and with this answer we should be able to get the whole thing. And these are all identical, so if we get this area, The whole area is just multiplied by 5. Okay, so we have a triangle and we want to find out the area. The first thing you should think for area of triangle is half the base by the perpendicular height. What's the base? Maybe we'd say the base is 6 and then we need the perpendicular height. Don't know it. It's actually quite hard to find, so that's not good. Is there any other way we can find the area of a triangle? If you have a look at your formula book, there is 3 formulas for the area of a triangle. Half the base by the perpendicular height is the most famous one. The second one is the one we're going to use, is area is equal to a half side by sine of the angle in between them. They just say A, B and C. But all that means is if we have a side, another side and the angle between it, we can get this area. The third way, by the way, you need all 3 sides. It's not used very much. I don't think I've ever seen it in the Leaving Cert. Even the honours, I don't think. Anyway, we're going to use this one. It's one you've learned in school, hopefully. It's one it is covered in the course, so hopefully you're able to do it. So area is equal to a half times the side, whichever side you want. They're both the same. So 6 times sine of the angle in between them. In this case, it should be 72. It looks like it's 75, but 72. We put this all in a calculator, or you can do some of it yourself. 6 by 6 is 36. Half of that is 18. Put this into a calculator and we would get, let me just check my notes, we would get 17.119 something. Rounded off to 1 decimal place, they asked. This is approximately equal to 17.1. So that's the answer for the area of the triangle. And let me just do it up here. To get the area of the whole thing, just 5 of them. There's just 5 triangles. 5 multiplied by, well, use the number that's in your calculator. Don't use this. It will get you a different answer in this case. The exam usually takes both, I think. But still, use the exact answer. It's still in your calculator. This number multiplied by 5 will get, let's see, we'll get 85.595 ... Rounded off, 85.6. Yeah, if you multiplied this by 5, you would get 85.5, which is slightly different. I think the examiner would probably give you full marks. They have in other questions, like they shouldn't. It's the wrong answer. This is the correct answer, but sometimes the examiner gives the wrong answer themselves, so who knows what they'll do in this case. Okay, let me rub this off and we'll go on to the next part. Okay, in part C, they give us the same shape, the pentagon, but it's been turned into this sort of a spinning sort of device. Yeah, there's an arrow in their picture. So you spin the arrow around and find what number you get. They simply ask you to write down every possible... Oh, sorry, it's spun twice. I'm sorry. They spin it twice and they write down... They get 1 and they get 4, let's say. They want you to write down every single possible outcome there could be. For example, you could get 1-1, 1-1. You could get a 1-4. You could get 3-2, and so on. Write them all out, and they tell you there's 25 of them. So this would be a really annoying question if you try to do it like I'm doing there. But that's okay. They give you a hint. They tell you it might be useful to draw a two-way table or to list it in a systematic way. So I'm going to show you how to do the table. And this is very common, these type of questions, to do heads and tails, red, blue and green. You can do all of that, what I'm about to show you. A table, one way here and one way the other way. So what could you get the first spin? You could get 1, 2, 3, 4 or 5. And the second spin only works for 2 outcomes. If you wanted to do 3, you'd need 3 dimensions. You'd have to use a computer for that. We can't draw it on the board. So the second spin, you could get 1, 2, 3, 4 or 5. Now again, you don't have to do this. If you didn't do this, it's fine. You could just write out all the answers and just get 25 of them. It's not actually that hard. I made it sound impossible. If you did it this way, maybe. But really, you did 1 1, 1 2, 1 3, 1 4, 1 5. That's all we're going to get over here. This is just how you could probably do this for any question and still get it. So you get 1 1, that's one of them, 1 2, 1 3, and so on down. I'll edit out here and I'll fill this in. And there we have all 25 of them. I can quickly check there's 25 because 5 multiplied by 5, there's 25 of them. And that's just a good way to do it so you don't forget any. Now it's still, you might see a mistake there, I'm not sure. It's still quite easy to make a mistake. That's all they want you to do for that question. But for part 2 of it, that's part 1, the list of all of this would be fine. You don't have to write it again over here, by the way. Just, it would be fine in a table. For part 2, they simply ask you, what's the maximum and minimum outcomes? Again, if you spun it twice and add the numbers together. Oh, sorry, it's the first time they're saying to add them together. So if you spin it twice and add the numbers together, what's the maximum number you could get and what's the minimum? This should be quite straightforward. The maximum is obviously 2 5s. They're down here, 2 5s. So the maximum, max is 10. 2 5s is 10. The minimum is obviously 2 1s. 2 1s is 2. That's it. There was no trick there. I'm guessing lots of students probably said, wait, it can't be that easy. It was. That happens in the exam all the time. It wasn't that hard of a question. Just wanted the maximum and the minimum. And then for the last part, part 3, they say each time the spinner is spun, each number is equally likely. So that's not always guaranteed. Maybe there's a bias to one of the numbers, but no, each number is equally likely. Find the probability of getting a total of either 4 or 5 when the two numbers are added. So how do you do this? How to get the probability is, so part 3, the probability P is equal to how many outcomes, what letter, I'm not sure what letter to use for this, I'm just going to write X in, but the number of outcomes that does what you're looking for. In this case, makes 4 or 5. So how many times will we get 4 or 5 up here? And divide that by the total outcomes. That's how you'd find the probability of most things. So this, how many different ways could we get a 4 or a 5? You could use this table here. This would be, gets 2, this gets 3, this gets a 4. Okay, there's a 4. 2 plus 2, that's a 4. 3 plus 1, that's a 4. What about 5? 4 plus 1 would be a 5. 3 plus 2, 2 plus 3, and 1 plus 4. In fact, these sort of go in patterns. All of them are 5. All of these guys here are 6. All of these are 7, and so on. They were a little mean to you. They probably, instead of this table, they probably could have got you to do a different table. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and write out the totals. So that's 2, 3, 4, 5, and 6. Instead of writing out this, I'm not going to do it again. Because you should still be able to do it. There was, how many, the ones I circled, 1, 2, 3, 4, 5, 6, 7. There were 7 outcomes that gets a 4 or a 5, and there's 25 total. So the probability of getting this is that there, 7 over 25. That's, did they ask you to round it off? No, that's the perfectly correct answer. But you can put it in a calculator as well, and you get 0.28. That's also perfectly correct. And I'm guessing they let you write that as percentage as well. 28%. That's usually the most correct way to write it. Decimals with a something between 0 and 1. But all of these numbers should be perfectly okay. So 28% chance to get a 4 or a 5. Okay, I hope that answered that part. I could probably talk more about that. I sort of like that, this sort of games and stuff, but hopefully that explained it. Ask in the comments if you have anything else. Let me clear this off and we'll do part D. So on to part D, we have a whole new game here. They tell us there's a new spinner and the things that can happen are N, S, E and W. Let me just say north, south, east and west just to easier to say. But that is a little confusing, because if you think of north, east, south and west, you're probably thinking of a picture that looks like this, all equal, north, south, east and west. But that's not what these numbers tell me. These probability numbers here tell me something very different. It tells me E is going to happen 40% of the time. That's nearly half of this circle. It tells me north is going to happen 0.3. That's more than a quarter, somewhere like here. Oh, sorry, that's north. It tells me south is going to happen a small number of times. That's something like this here, south. And west is going to happen even less likely. West like that. That's more what these numbers are showing me. If you've got a spinner around here, you're most likely to land on east or north. So you're most likely to win a euro or zero. And this €5 here that you're thinking, oh good, I pay a euro, I'll win €5. That's not very likely at all. It's this small number. Anyway, that's probably why they asked a question like this. They use north, south, east and west to make you think like this, confuse you a little. Sometimes the examiner wants to confuse you. It's the best way to test which students don't get confused, which students can look at the maths and figure out what should be done. Anyway, this question, they explain this game to you, and then they ask you simply, is this game fair? And to work out the expected value as part of your solution. Now what they mean by fair is if you pay a euro, it would be fair if you got a euro back. Now, it's not real. In real life, that doesn't happen. But still, that's what they mean by fair. You pay a euro, you get a euro back on average. You won't always get a euro. Sometimes you get less, sometimes you get more. But if it's fair, you should pay a euro and get a euro back. Maybe it's a really good game, you get more than a euro. It's not fair, but that'd be really nice. Usually we get less than a euro, and I'm guessing that's what we find here. The examiner doesn't like to show you a game you can win. So how do we do this? We work out the expected value. And again, we can do this for any gambling game. You can do it for the lotto. You can do it for flipping a coin. You can do it for anything. I'll show you how to do it here, and then you can try it for any other game. And it's really useful. It lets you realise, oh, I don't want to play that game. It's really unfair. Some gambling games, you only lose a little, some you lose a lot. So it's really useful to know which is which. And if you're really lucky, maybe you'll find one that you can win. It happens, it's very, very rare. It means the casino or whoever made a mistake. Anyway, in this case, what would I expect to win? So I bet a euro, and I would expect north to come up sometimes. I would expect to win €1 from north, and I'd expect to win it 0.3% of the time. Then I would also expect south to come up, and I would expect to win 50 cents. And I'd expect that to happen 0.2% of the time. Then also I would expect east to come up. I'd expect to win 0, and I'd expect to win that 40% of the time. And then lastly, I would expect west to come up, and I would expect to win €5, and I would expect that to happen 10% of the time. That is your expected value. And this could be done at any gambling game. For example, the lotto, you could write out, I expect to lose, I expect to get 0, 99% of the time. I expect to get 3 numbers and win €2, like 4% of the time. You can look these numbers up online somewhere. And I can expect to win €1,000,000 a very, very small number of times. And you can add all them together. And you can find out, I think I did this before, for every euro you bet in the lotto, your expected value, your EV, is something like 0.4. Like it's, you're not going to win much. So what is it in this case? If you put all this into a calculator, so this is 0.3 plus 0.1 plus 0 plus 0.5, you should get 0.9. So remember, you bet €1 on this game and you expect to get 90 cents back. €0.9 back. So Well, that's its expected value. So the answer to is this game fair? No, it's not. I pay €1, I only get 90 cents back. And then it asks you why it's not fair. And that's just what I said. 90 cents is less than €1, or 90 cents is not equal to €1, I guess is more correct to say. It's not a terrible game, I have to say. You lose money, but there's a lot of casino games are very similar to this. You might go into a casino and think, I can win money. You can, but you expect that you will lose a bit. Every time you bet, you'll lose a little bit. Okay, hopefully that answers that question, and that answers all of question 10, and question 10 finishes all of paper 2, and paper 2 finishes all of Ordinary Leaving Cert 2023. I hope I was helpful in this question or any of the other questions. If you do have follow-up questions, please leave them in the comments below. Thank you for watching, good luck in your exams, and I'll see you next time.